Hi, this is Bob Steele here with another GCSE Maths revision slash exam prep video. I know you've not got your usual summer exams, but everybody's preparing for some sort of mocks or assessments that are being given to year 11s or resitters in college. So I'm going to run through most of this excellent Corbett Maths paper. Chose this just because the selection of questions I think is very similar to the sorts of things you can expect to find on a GCSE paper. I'm going to go through just answering questions and explaining methods and so on. Hope you find it useful. Right. First few questions are usually quite easy lead-in questions. So take a look at this. The number you're given is between 2,800 and 2,900, but with the middle being 2,850, you can see that it's nearer to 2,800. When you get a question like question 2, you should be aware that the different parts can be moved around. Yeah. As long as whatever plus or minus is to the left of a term stays there. Yeah. So the plus stays with the 3W, the minus stays with the 6W. You could write it that way around if you find it easier, and then you've got this bit is 8W minus 6W leaves you with 2W. Factors, that's everything that goes into 24. My advice is to find them in pairs. So 1 times 24, 2 times 12, 3 times 8, and 4 times 6. If you find them in pairs, there's much less chance of you missing any. Right. Bus leaves Ballymena at 17:12, so arrives at Temple Patrick. Yep. Try that again. Okay, just trying to highlight that, but it's not working. 1750. So that's that. From 17:12, that's 38 minutes. That's just the 50 minus the 12. That sort of question gets slightly trickier if it crosses the boundary between 1 hour and another hour, but this is all within the 5 o'clock hour. So the express bus, so this first one and this third one arrive at 10 past the next hour. This one arrives exactly at the start of the next hour. So it's 10 minutes shorter. So that's the answer that we're looking at for the part C of the question. Okay. Yep. you are expected to be on top of your unit conversions. So here we've got litres, here we've got millilitres, so you do need to know that 1 litre is 1,000 ml. Once you know that, there's a couple of different ways you could go about that. You could turn everything into millilitres. So, for example, you could turn this 8 litres of lemonade into 8,000 ml. Then you've got 14 children each drinking so there's the calculation, 3,920. So if you subtract what gets drunk, what's left? So see, there's a big clue here. You've got millilitres on the answer line. So if you're going to be answering in millilitres, it makes sense to convert to millilitres right at the start. Okay. So this 20 sweets is represented by 2.5 symbols. Sweets symbols. So 20 sweets. I'll write that as using a decimal. Now, if you're comfortable to do 20 divide 2.5, you'll get 8. You'll work out that the key is that 1 circle equals 8 sweets. Now, I've taught some students who might not be totally comfortable with being able to divide by decimal. So another option you have is to say, well, 20 sweets is represented by 2.5 symbols. Then if you were to repeat that, then you'd have 40 sweets represented by 5 symbols. And you might find 40 divide 5 an easier bit of maths to do. Still going to give you 8, but an alternative way to get to your answer. Then 8, 16, 24, 32. Remember that's 20. So these two, red and blue, between them add up to 52. So there's 18 left. And of the 18 left, let's have a look. There are twice as many blue and white. So if blue is blue's 20, that means white is 10. So that will be 8. Bit tricky, but that's my attempt to draw a quarter. If the whole circle is 8 sweets, then a quarter of a circle is 2 sweets. So there's my 10. So 20, 30, 62. There's 8 left. So that's 1 circle for green. And just a quick check, everything adds up. Okay, next. Tip for this type of question, don't use a protractor. Unless something explicitly says it's drawn accurately, then you're expected to calculate, not measure. In fact, if you measure, you'll almost certainly get the question wrong, because the examiners will have made the question such that it's not accurate, so measuring will guarantee that you don't get the right answer, because you're being made to do it using a calculation method. So what I suggest is, got a straight line here. If we know this angle, then we can work out x, because these two are on a straight line together. But before we can find this angle, we're going to have to find some other angles within the triangle BCE. So with what we know about angles on a straight line adding up to 180, see, these two angles both meet at C. So there's 107, because they add up to 180. And there is 26, because these two add up to 180. But please don't make the mistake of thinking that these two angles are connected or related to these two angles. They're not. They're quite separate. These two meet at C, these two meet at B. So what have we got? We've got 107, and we've got 26. 133. Take that away from 180. That leaves you with 47, because the angle sum of a triangle is 180. Now you've got your 47 there. X is 133 degrees. Right. When you get this sort of an estimation question, what you're being asked to do is, what I'm suggesting is, take your ruler and measure that. And then measure the height of the truck, lorry. I'm going to compare these two distances, or these two lengths. So if, for example, you think that the height of the truck, well, when you measure them, if this distance is double this distance, then your estimate would be that the lorry is twice the height of the man, which would be 4 meters. If, on the other hand, you do these measurements and you find that the lorry is 2.5 times the height of the man, then you do 2.5 times this. Can't really get an on-screen ruler here, but by eye, to me, this looks like a bit more. I'm kind of feeling that would be another 2 meters. So for me, as I'm demonstrating this and I can't put a ruler on the screen, that's looking like about 4.5 meters. But if you do it as I suggested with a ruler, you should be able to tie that down quite closely. A 100 can be found by adding together a square number and a cube number. So let's have 2 lists, square number, cube number. 1 cubed, 2 cubed, 3 cubed, 4 cubed, and then let's have some squares. Okay, these two would do it. So what we've got there is 6 squared plus 4 cubed is 100. So 36 in there, 64 in there. There is no particular method to apply to that. You have to list the square numbers, list the cube numbers, and find something that fits. Okay, an unknown sum of money. So what's been spent? £12. And this is 10 pence short of another £10. So we spent £21.90. Interesting that this is in fifths. So I would make a sketch, draw a block, split it into 5 parts. If he has 2/5 left, then 3/5 is what he has spent. So the £21.90 is the 3/5. So I'll divide the £21.90 by 3. If I do that, can it give me £7.30 on every section, including these 2 sections? So the total amount of money to start with must have been 5 lots of £7.30, which is £36.50. And there's my working out to go with it. Or you could just say these two are 1460, and you could add it up this way. Okay, when a tennis ball is dropped, it bounces and then rises. But each time it rises, it only goes back up to 80% of the previous height. So what I would draw for this is start out at height of 4 meters. You drop your ball, comes back up, but only to 80%. It comes back down, it comes back up, but to only 80% of the previous level. It comes back down, it goes back up to 80%. We get this sort of a pattern where each peak is 80% of the previous peak. So now that I've got my sketch, I'll get my calculator. 40 times 0.8 equals. And then I times by 0.8 again. And again. So the height after the first bounce is here. Second is this. See how useful this sketch is? I'm a massive fan of sketches for anything to do, anything like this. Also fractions, ratios. For how many bounces does the ball rise to a height greater than 2 meters? Once, twice, 3 times, yeah, because this next one, by times by 0.8 again, will go below 2 meters. So my answer is 3. And if you want to put, if you want to put that to the test, you times, oh, I've still got it on screen, times 0.8 and 2 decimal places, we got 1.64. So again, this is something else that could benefit from a sketch. For every 4 arrows fired, 3 hit and 1 misses. So if Emma hit the target 24 times, then the 24 has to be spread across here. So 24 split 3 ways, 8, 8, 8. If all of the parts of this sketch are 8, then 32 arrows were fired. Yeah, 8, 8, 8, 8, add together 32. So, look, 3 times this is 6, take away 2, it's 4, 3 times 1 is 1, sorry, 3, take away 2 is 1. You see a pattern here going down by 3, so this will be minus 2, this will be minus 5. So what I have seen some students do in the past is just mark these points and not finish it off by taking a ruler, a pencil, and just drawing a straight line all the way through. If you do that, that will cost you a mark. Using the app that I'm using at the moment, I can't put a ruler on the screen, so that's come out better than I thought, actually. But if you did that with a pencil and a ruler, it would be perfectly straight. So when y equals 5, we come across here to there and go straight down like so. Again, do that with a ruler. So your estimate, that's 2, that's 3, that's 2.5. It's definitely nearer to 2.5 than it is to 2. So my estimate, I'm going to go with 2.4. Whilst I'm here, I'll show you how that could be calculated. There's your graph equation. So when y equals 5, do a substitution. 5 equals 3x minus 2. So for you to add 2 to both sides of this equation, you get that 7 equals 3x, or 3x equals 7 if you now want to switch the sides around, which is perfectly valid. things either side of an equal sign can change places. And then divide by 3, you'll get the x. Well, if you want a totally accurate answer, 2 1/3. If you've used decimals, you'll get 2.3 recurring. So, not seeing the answer scheme for this, but I would expect that anything in the range 2.3 to 2.4 would be accepted. Because we were asked to estimate, yeah, I'm not saying you were expected to do this calculation. I'm just showing you how you could do the calculation, just to show you that our estimated answer is accurate enough for this 1 mark. So, how did we get from A to B? Well, it looks to me, if I draw this line through the middle, which is the line y equals 1, we've done a reflection. Yeah. So, 2 mark question, 1 mark for actually choosing something from reflection, rotation, enlargement, translation, choosing one of those. So it's the reflection, and the 2nd mark comes from saying what the mirror line is. So there you go. How do we know it's a reflection? Well, we can rule out other things. It's the same size, so it's not an enlargement. It's not the same way up, so it's not a translation. It could possibly have been a rotation, but far simpler is a reflection. Yeah. If you actually had this on a piece of graph paper and you folded the paper across this line, and this point would sit perfectly on top of this point, yeah, this point on top of this point, and this point on top of this point, because they're each the same distance either side of the mirror line. Okay. So in each pattern, the number of reds is increasing by, we start out with 3 reds, and we've got 5, we've got 7, and so on. So if we look at this pattern that's emerged here, this number is going up in ones, just like the pattern number is going up in ones. This number lags 1 behind the pattern number. That, I'm going to put in 19 in there. 2 19s are 38. Add on 3 gives you 21. So the reds go up 2 at a time, and the yellows go up by 1. So here you had 3 yellows, 1 yellows, 5 yellows. So the number of yellows is 2 greater than the pattern number. Pattern 2 has 4, pattern 3 has 5. So pattern 10 would have 12 yellows. So that statement is false. Number of red squares, 3, 5, 7, 9. Start off odd and add even numbers. You'll always have odd numbers. Every pattern has more red than yellow, while this pattern has 3 of each. So that statement is false. Does pattern 5 have 11 red squares? No. Already established that we're going up in 2s for the red squares. So that's true. A bit of zoom, see that better. There we go. If you get a box within a box question, I have a tip for you. Rather than work out this volume and work out this volume and see how many times this goes into this, my recommendation would be to look at these measurements. Say, right, here we've got width of 50, width of 4 meters, which is 400 centimeters. So you can get 8 boxes across. So 50 goes into 400 8 times. And then into this 600 centimeters, which is your depth, your front to back. You can get 12 boxes deep. So 50 goes into 600 12 times. If you needed to do these calculations with a calculator, 600 divide 50, that's where I got the 12 from, 400 divide 50, that's where I got the 8 from. And $50 centimeters goes into 150 centimeters. So I should also point out that I'm relying on the knowledge that 1 meter equals 100 centimeters. So you'll get 3 boxes high. So you'll get your answer from 8 times 12 times 3. There you go. You can fit 288 boxes into that container. And we didn't have to work out that volume, and we didn't have to work out that volume. Factorize. 21 and 7, both in the 7 times table. So I'm going to take a factor of 7 out of both terms. So if I divide this by 7, I'll get 3. If I divide this by 7, I'll get A. Now, factorize fully means to get full marks here. We have to take all possible factors outside the brackets. Now, as well as recognizing that 6 and 9 are both in the 3 times table, you're also expected to recognize that x squared and x have a common factor of x. So this is the answer that would get you full marks. I have often seen, and I'll show you here, I've often seen this, and students wondering what they've done wrong, because when you multiply this out, you do get back to what you started with, yeah? This answer will get you 1 mark, because it's only a partial factorization. You've still got x's inside the brackets. So it's not fully factorized until everything that's in common is outside the brackets. Yeah, so this is the one we like. This is our 2 marks answer. Okay, next we've got an end term question coming up. So right, you need 2 parts to do this. First thing you need is difference term to the next. So this sequence is going down. Please start our nth term with 3n. Then 0 term, which is here, 1 term to the left of the first term, be positive 13. So there's our nth term expression. And the way you would use that nth term expression to do this is by substitution, like so, and there's your plus 13. So this part gives you minus 150. You add 13, you've got to remember to go the right way along the number line. I often see people getting this wrong and getting something involving 163 in their answer. They've added 13 to 150. If you add 13 to negative 150, your answer will become less negative by 13. That's the answer you should be looking for. Okay, not seen one quite like this before. Might take a bit of reading here. This is the least value for money. Well, I think I'm going to start out by saying 180 divide 4 means if you buy a 4-pack, they are 45p each. The best value for money is 352 divide 8. 44 pence. Okay, not much in it. If that's the least value for money, and that's the best value for money, then the 6-pack must be somewhere in that range. So 6 bars at 45 pence, that's going to be £2.70, and 6 bars at 44, yeah, 44 times 6, so if the 6-pack was priced at £2.64, it would be equal best value. So we might be expected to say, well, to not be equal best value, it would have to be priced at least a penny above that. And here, to not be equal worst value, yeah, so we might need to narrow those ranges by a penny. Okay, the modal class interval. Well, see, the highest frequency is here. What that's telling us is that 17 puppies have a mass of between 4 and 5 kilograms. So this interval is our modal one. What fraction of the puppies have a mass of greater than 4 kilograms? There's 70 there. Or 4 kilograms, above 4 kilograms is these plus these. So that would be 29 out of the 70. So we would write it like that. Okay, when you draw a frequency polygon, okay, so 0 to 1, frequency of 7. So that's here. So we find the midpoint of that first interval. Yeah, so the midpoint of 0 and 1 is a half. Yeah. The midpoint of the next interval is 1.5. So we plot the next frequency like that. Each one of these little squares is a half. So that should be there. 13 is there. Next one along, 15. That's halfway between 2 and 3. There. Then we've got 6, 17, and 12. So 6 is there. 17 is there. And 12 is there. And when you draw a frequency polygon, you take a ruler and you join your points together with straight lines. So without a ruler, I'm quite pleased with that. Okay, so that's as much as we're going to cover in this one. Hope you've found that useful as part of your revision. I shall sign off here. Thanks for watching and listening.